Hi everyone, welcome back to AP Environmental Science. I finally fixed this recording thing. Not that any of you care, but Google now has like an integrated recording thing rather than doing it through a third-party software. So that was the issue, but I'm back. Hello, hope you guys are all doing well. We're moving into Unit 6, which is a really short unit all about water and ocean uses. So things like overfishing, watersheds, eutrophication, all about water, okay? All about water. And again, you should have either a physical copy of the notes that you will get in class, or I did post the virtual notes as well on Google Classroom for you if you choose to go that route. There will be a test for Unit 6 and 7 combined, a physical test in class, not a take-home, not a midterm. It'll be a physical test in class, okay? All right, so let's go ahead and get started. So topic 6.1 is all about watersheds. All right, so what is a watershed? A watershed is all of the land that drains into a specific body of water. And a body of water can be anything, a river, a lake, a bay, a stream, as long as it's a significant body of water where you have other sources of water draining into it. So it's determined by slope, and slope is, the steepness of the surrounding land. So the geography of the land is going to determine the boundaries of a watershed. So what's an example of this? Let me move my head over. Oh yeah, and I can make myself nice and tiny. And I can go over here. Oh, so cool. Okay, so what exactly does a watershed look like? It looks, something like this. And I actually have a picture of a watershed, one of the ceiling tiles a student painted for me a few years ago of, a watershed. So if we look here, this is just, a random old watershed. This is showing us elevation, the height of the land. So back here, we have precipitation, it's raining, and water is going to trickle down. And what's causing it to trickle down? Gravity. And the slope of the geography or of the mountain, whatever you want to call it, the slope of it is going to impact where the water is going to flow, as well as any land masses, ridges, so on and so forth. So this water will run off in two different directions depending on that. So imagine a watershed is kind of like a funnel, and the water is going to kind of flow into a central body of water depending on the slope. But there are a few different other things that do impact what forms a watershed and also how much water is going to get into a watershed. So, and a few of these are actually things that we are a little bit familiar with. So vegetation. The more vegetation you have, and vegetation is just a fancy word for plant life, the more vegetation you have, the more infiltration of groundwater you will have and the less runoff. So as a reminder, infiltration is water infiltrating or seeping through, getting through the soil, and groundwater is water that's simply found underground. So how does vegetation do this? Well, the root system of the plants actually make the soil more porous, meaning that the pores, the space in between, it's able to absorb more water because the pores are bigger. The root systems break apart the land and kind of give it this nice anchor. It's this nice, sturdy yet porous structure that allows water to be absorbed. Whereas if you didn't have as much vegetation, you just have a flat land, kind of like a parking lot, you're not going to have the water absorb into the ground. It's going to run off into a watershed, okay? So the more vegetation you have, the more infiltration and more groundwater recharge, which is good because our primary source of fresh water is from the ground. The greater the slope, the faster the velocity of runoff, and that also causes more soil erosion, which is, the degrading of soil over time. If you do have vegetation, again, plant roots do anchor soil into the ground into each other. But if you do have a bigger slope, water is going to rush down faster. That's something that you guys should remember from physics. And soil permeability, again, permeability is how water is absorbed, how fast it's absorbed into a substance. And in terms of soil, it's determined by the size of the particle and the size of the pore particle. So if we remember all the way back from our second unit, the three particles we have that make up soil are sand, silt, and clay. Sand is the biggest particle size and therefore has the largest pore. So because sand has the largest pore, it's the most permeable. So water is going to permeate or percolate or infiltrate, all synonyms. It's going to go through the larger pores the fastest and the easiest. It's kind of like you're draining a shower or draining a tub. If the drain plug is released and you have a really big drain, more water can go through at a faster rate. Whereas particles like silt and clay, they are smaller, with clay being the smallest particle and the smallest pore size. So depending on your soil composition, you're going to have different rates of runoff and infiltration. I don't know what. Okay, it was a little weird. Okay. Okay. I don't know if you guys can hear that, but the bell just keeps ringing. Okay, sorry.
Attention all students that are taking a portfolio bus at 3:45. Please start making your way to door 19 on the first floor.
Okay, sorry. That was weird. Okay, so, let me, boop, 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 boop. Oh, wait, no, that's not what I wanted. Yeah, that's good. So, human activities, of, okay, hold on. My brain just like lost train of thought. So, essentially, to wrap this up really quickly, a watershed is just an area of land, and then depending on the slope, the vegetation, what kind of soil you have, it's going to then impact where the water flows when it rains. So New Jersey has huge watersheds. New Jersey does have a lot of wetlands as well. I did try to get a field trip approved to go to the Manasquan Reservoir watershed, and that was shot down. But, regardless, we, depending on the kind of usage we have of the land, so the urbanization, which, building cities and development, clear cutting, the permanent removal of all trees, those activities do impact watersheds as well as groundwater recharge, as we should know from Unit 2. When you increase your impervious surfaces like concrete, buildings, whatever, you're going to decrease your groundwater recharge because water cannot percolate through impervious surfaces. Okay. So now let's talk about one of the biggest watersheds in the entire country, which is the Chesapeake Bay watershed. So the Chesapeake Bay watershed is a 6-state region that drains into a series of streams and rivers and eventually into the Chesapeake Bay. And the Chesapeake Bay is over here in this area. I don't know if you guys can see my mouse. If you can't see my mouse, it's where that little red oval thing is. But it's near like Maryland, Virginia. It's over there. Okay, so not too far away from us. So it's a mix. It's a mix of fresh and salt water. So this would be like brackish water, a mix of fresh and salt, something kind of like an estuary. So because it's a mix of that fresh and salt water, it does have a lot of nutrients in the sediment, and it forms this estuary, which is like a nursery where a lot of shellfish and sea life will actually go to lay their eggs or have their spawn, which are their babies. So because of this, these estuaries and these watersheds, in the case of the Chesapeake Bay one, they are highly productive. Remember, productivity is the rate of photosynthesis. Okay, the rate of photosynthesis. The more productive, the higher the rate of photosynthesis, which means you have higher rates of plant life, which is good because plants are at the bottom of the food chain. So this is kind of what a lot of watersheds look like, including the Chesapeake Bay. It is a mix of aquatic life and, aquatic life on land and aquatic life that, plant life that is aquatic and plant life that is going to be on the land. You can tell I haven't done this in a while. So throwing it back to the ecosystem services from our Unit 4, our supporting, our provisioning, our regulating services, estuaries and wetlands provide ecosystem services. Tourism is a huge thing. These places are incredibly beautiful. If you are a nature lover, I highly recommend to check out any of the watersheds present in the state of New Jersey and around the area. They're just gorgeous and filled with so much biodiversity and life. So because of that, you're going to have cities and tourism and hotels near these areas so people can go see them. Water filtration is great because the water that's going to rain down or the water that's in the watershed might be polluted from a variety of reasons, but the root systems of the different aquatic grasses can absorb and trap the pollutants, which is great. And it's, a gigantic habitat for all of this food. Remember, photosynthesis, plants, bottom of the food chain, higher productive, more biodiverse because you're supporting, a wide variety of everything else in the rest of the food chain. And storm protection as well. Here's just a few pictures of that stuff. So how do the humans impact the Chesapeake Bay? And this is a lot of things that we have already talked about, just in more like specific concrete examples. So nutrient pollution of nitrogen and phosphorus, and as nitrogen, P is phosphorus. This can lead to eutrophication in the bay. You guys should know what eutrophication is by now. If you don't, it's when you have these excessive nutrients, these limiting nutrients like nitrogen and phosphorus that, normally don't exist in high quantities and they're needed for survival. Suddenly they're in high quantities due to human activities such as like fertilizer runoff. So when you have these increased amounts of your limiting nutrients, they cause an algal growth. And I know I just said the higher productivity, great, we have more biodiversity, more life. When it's too much, that's bad. Like, we like staying in a balance. Nature likes staying in a balance, and eutrophication is too much. So now you have an algal bloom due to increased nitrogen and phosphorus. Because of this, the algae grow a lot, and they form this really thick layer of algae on top of a body of water. And it's so thick that the light cannot penetrate through, meaning that any submerged aquatic plants that live like near the bottom but still in the photic zone, which gets the sunlight, they can't do photosynthesis. Also, remember that plants do cellular respiration, so they're going to be absorbing the oxygen or using that oxygen in the water to do cellular respiration as well. You also will have then, like, because the plants on the bottom are not getting the sunlight they need, they will die and decompose. The bacteria that eat the dead plants are going to perform cellular respiration. Bacteria do that, by the way. And they're using up all the oxygen as well. So now you have these decreased oxygen concentrations. So all the fish living there, they're going to die. So that's a very abridged version of eutrophication. So what are some major sources of nitrogen and phosphorus? Discharge from sewage treatment plants. That is our next unit. Animal waste from CAFOs, which are going to be the things that we were discussing in Unit 5. So the waste produced from the meat industry. And of course, synthetic fertilizers as well. And other major pollutants are endocrine disruptors, sediment pollution, which can occur from deforestation, urbanization, and that can increase the turbidity, which is like how clear the water is, how well you can see through it. And I know I have, some more pictures there that you can see. Okay, so in terms of the effect of clear cutting on watersheds, as you guys should maybe remember, clear cutting is the permanent removal of trees in an area, and you are massively cutting them down into big swarms, cutting them down. So I just said earlier how root systems, vegetation, they're going to help with the water runoff because they create these pores that allow the water to seep through. So when you are doing this massive removal of trees and vegetation, you are going to increase your rates of soil erosion. So you're going to have more runoff of water because you no longer have that stabilizing root system. The soil is going to become compacted, but also it's going to create like this unstable structure on top where the water is just going to slide right off and carry with it the sediments, which could then lead to the water becoming more turbid, which is how cloudy it is. Also, because of this, you're going to have like a loss of tree cover. So, trees, really big ones, they underneath will have shade. If you get rid of all your trees, the sunlight is going to be hitting it and warming the soil and warming the stream, which is not good because all life on Earth has an ecological tolerance. If you raise the temperature by 1 or 2 degrees of a stream, that could mean massive death of anything that's adapted to live in a, more cooler temperature of the water. So solutions to watershed pollutants. There are a ton. And the two main ones that you really can remember are things to prevent erosion. So the very first thing is cover crops. This is like label A in this diagram. So cover crops, if you recall from Unit 5, cover crops are when you plant a specific kind of plant in between the target plant. So let's say you have a potato, rather than growing a potato next to it, you're growing something else and then a potato. And the purpose of this is to essentially stabilize the pasture or stabilize the farm field. So what this does is it's going to make sure that the soil is staying in place and increasing the strength of the pasture, which is good because you're going to prevent runoff of these nutrients. So if you are using fertilizer in these fields, the one with the cover crops will have more uptake of the nutrients and less runoff because the root system is stable. Okay, it's kind of like building a house. Rather than all being made out of wood, it's made out of wood, then brick, then wood. It's stabilizing the structure. Okay, so when you do this, you're preventing runoff into the local body of water, which would prevent eutrophication, which is excellent. The other thing, which is kind of like common sense, which a lot of this stuff is, the animal manure management. That's exactly what it sounds like. Making sure that you're actively managing and sanitizing and taking care of your animal waste. Animal waste has so much excessive nutrients in it, so much phosphorus and nitrogen and ammonia, and those are all things that plants need to grow. A lot of natural fertilizers were made from cow poop and animal waste. So you have to really make sure, not you, but businesses really have to make sure that they're effectively managing their animal waste to prevent runoff into watersheds and causing eutrophication and algal blooms. And I think that's it. Yeah. Okay. That is all. I'm so sorry that was so long. I talk a lot. I'm going to try and not talk as much next time. If you have any questions, let me know. Okay. Bye.